In this video, we're going to solve a quadratic equation that has some fractions in it, and we're also going to do an application that has quadratics in it. We're going to start with this equation, 1/2 x squared plus x over 5 equals 1. I start by getting all the terms on one side. That's done by subtracting 1 from both sides. Then I get rid of the fractions, and you can do that by multiplying by the common denominator 10 on both sides. We multiply by 10 on the left and 10 on the right. 10 times the right side is just 0. On the left side, we have to make sure and distribute that 10 through all three terms, and we get 10 halves x squared plus 10x over 5 minus 10 equals 0. Now this simplifies to 5x squared plus 2x minus 10 equals 0. Now we can solve this equation. We can try factoring it, but it just won't factor. So we turn to the quadratic formula, plugging the coefficients a, b, and c into the formula, where a is 5, b is 2, and c equal negative 10. And when we do that, we get x equal negative 2 plus or minus the square root of 2 squared minus 4 times 5 times negative 10 over 2 times 5. And that simplifies to negative 2 plus or minus the square root of 204 over 10. Now that's our answer, but we can simplify the form of that answer. We can replace the square root of 204 with the product square root of 4 times square root of 51. Square root of 4 turns into 2. And then we can factor a 2 out and get 2 times the quantity negative 1 plus or minus the square root of 51 over 10. Then we can cancel the factor of 2 out, and we get negative 1 plus or minus the square root of 51 over 5. Now that gives us two answers in decimal form. The square root of 51 minus 1 over 5, which is 1.228 rounded off, and also negative square root of 51 minus 1 over 5, which is negative 1.628. Now here is a neat trick that you're going to thank me for. If you go to mathwarehouse.com and find their quadratic formula calculator and solver, and put in the coefficients 0.5 for a half, 0.2 for the 1/5 coefficient, and negative 1, you can solve this quadratic equation. It not only solves it, it gives you the decimal and radical form, and we get our two answers, 1.228 and negative 1.628. Or if you want the radical form, we put in our simplified equation without the fractions, 5x squared plus 2x minus 10, and hit the button, and this calculator not only gives you the solutions, but it even shows you how to simplify the radical. Isn't that neat? Now, I'm not saying you should not learn how to do this. I'm saying use this as a nice tool to check your work and see where you made a mistake. And here's the complete URL. I had to break it up in 2 lines because it was so long. You go to mathwarehouse.com/quadratic/quadratic formula calculator.php, and it'll take you right to the calculator. In this next example, we're going to look at a marketing application that involves a quadratic formula. Oftentimes we see how candy bars and boxes of cereal have been just getting smaller and smaller each year. This example deals with that. Here a candy bar has dimensions 5.5 inches by 2.3 inches by 0.25 inches, but the manufacturer wishes to make a new candy bar with 10% less weight and volume that has a height of 0.23 inches. The length of the new bar should be 2.4 times the width, because that was the ratio of the original candy bar. And what are the dimensions of the new candy bar rounded to the 100th of an inch? What's helpful in a problem like this is to draw a sketch. And here I have a sketch of the old candy bar and also the new candy bar, and I put in the numbers where I have them. I have the length of 5.5 inches and I have the width of 2.3 inches. I can put those in, and the depth of 0.25 inches. And we also know that the depth or thickness of the new bar is 0.23 inches, so I'll put that value in. We can also get the volume of the old candy bar by multiplying together the dimensions, and we get length times width times height equals 3.1625 cubic inches, or I've put that value in here on the old candy bar sketch. Now we can figure out what the new candy bar volume is because we know it's 10% less or 90% of the old candy bar. So we take our volume of 3.1625 and multiply by 0.90. When we do that, we get 2.84625 cubic inches, or I'm just going to round it to 2.846 cubic inches. And I can now put that value in as the volume of the new candy bar in my sketch, and we can get an equation from this now. If we let W equal the new bar width, then 2.4W will be the length, and we get length times width times height equals 2.4W times W times 0.23, and that equals our new volume of 2.846, and that simplifies to 0.552 W squared equals 2.846. Now we get the W squared by dividing both sides by 0.552, and we get W squared equals 5.156. We solve this by square rooting both sides, keeping only the positive answer because this is a dimension. And we get W equals 2.271, rounded off to 2.27 inches. And that means the length is 2.4 times that dimension of 2.271, and that rounds off to 5.45 inches. So our dimensions are 2.27 by 5.45, and we can check this by multiplying length times width times height, and we get just about 2.845, which is very, very close to our 2.846. So we have the correct answer.